Today we're going to talk about building functions from functions. All right, sum, difference, product, and quotient of functions. It says let f and g be two functions with intersecting domains. Then for all values of x in the intersection, the algebraic combinations of f and g are defined by the following rules. If you take and you add two functions together, it's the same as saying the f function plus the g function, basically combined like terms. Same with the difference. Product, same thing. Quotient, same thing. In each case, the domain of the new function consists of all numbers that belong to both the domain of f and the domain of g. As noted, the zeros of the denominator are excluded from the domain of the quotient. All right, so here we go. It says find the formulas for the functions f plus g, f minus g, f times g, f divided by g, and g times g. Give the domain of each. So the first thing it wants me to do is f plus g of x. And that means you take the f function, which is x squared, and you add the g function, which is the square root of x plus 1. And there's nothing else I can do to simplify that, okay, because you can't combine an x squared and a square root function. So now all I have to do is the domain. Well, the domain the no-no that I have is the radical, so I have to say, Mr. Radical, you must always stay positive. So if I solve that, square, square, I get x plus 1 has to stay greater than 0, so x has to stay greater than or equal to negative 1. Which means I can include negative 1 and everything bigger. So there's my domain. So my domain is going to be from negative 1 to infinity. There's f plus g. F minus g of x is going to be x squared minus the square root of x plus 1. Same domain because I have the same restriction, negative 1 to infinity. F times g of x would be x squared times the square root of x plus 1. Again, there's nothing I can do to simplify that. Same restriction, so my domain is negative 1 to infinity. F divided by g of x is going to be my f function divided by my g function. And now we have some drama, okay? What this means is that, yes, that x still has to be greater than or equal to 1, but now it's also a denominator. So I also have to say, Mr. Denominator, you may never equal 0. Square, square, I get x plus 1 can never equal 0, so x can never equal negative 1. So the only difference is this is going to be an open circle. So for my domain, instead of including negative 1, it's going to be a round bracket because it won't be included. Okay? And then it wants g times g, which means take the g function times itself. And if I do that, a square root times the square root of the same thing is just itself. But I'm still going to have the domain restriction, even though the square root canceled out and it doesn't look like I have any drama anymore. That drama is still there, so I still have to say negative 1 to infinity. Okay? Alright, so if we try another one, they want me to do f plus g. So if I do f plus g of x, I'm going to have the f function 2x plus 1 squared plus the g function 5 minus 3x. If I simplify that, I got to make two copies of 2x plus 1 so that I don't, sorry, my thing's a little bumpy, so that I don't kill puppies. So I got to make two copies of that plus 5 minus 3x. So if I FOIL, I get 4x squared plus 2x is plus 4x plus 1. Distribute the positive, plus 5 minus 3x. Combine like terms, and I get 4x squared. 4x minus 3x is 1x. 1 plus 5 is 6. So there's my sum. In my domain, I have no drama. There's no denominators with x in them. There's no radicals with a letter underneath them. So my domain is negative infinity to infinity. Okay, there's f plus g. If I do f minus g of x, that's going to be my f function minus my g function, which is going to be 2 copies of 2x plus 1, so I don't kill puppies, minus 5 minus 3x. Watch that negative because it's going to change signs. So again, if I distribute, I get 4x squared plus 2x is plus 4x plus 1. Distribute the negative, I get minus 5 plus 3x. So now when I combine like terms, I have 4x squared plus 7x minus 4. And my domain, again, no drama, so negative infinity to infinity. Oops. Come on. Okay. So we did f plus g, f minus g. They want me to do f times g. That would be 2x plus 1 squared times 5 minus 3x. Excuse me. So when I simplify this, I'm going to have 2 copies of 2x plus 1 times 5 minus 3x. I'm going to go 2 at a time. So again, 4x squared plus 2x is plus 4x plus 1. And then I'll multiply that by the 5 minus 3x. That's going to give me 20x squared minus 12x cubed plus 20x minus 12x squared plus 5 minus 3x. Combine like terms, and I'm going to get, let's see, negative 12x cubed. I have 20x squared minus 12x squared, which is going to be positive 8x squared. I have a positive 20x and a negative 3x, which is going to be positive 17x. And then I have a positive 5. Okay, which somehow I forgot there. Yeah, plus 5. I forgot my 5. Anyway, plus 5. So there's my product, and again, there's no drama. So my domain is negative infinity to infinity. Okay, then they want f, oh darn it. Then they want f divided by g. F divided by g of x is going to be my f function, which is 2x plus 1 squared, over my g function, which is 5 minus 3x. And I could simplify the top, but nothing's going to cancel, so as far as division goes, I'm done. But now we've got a no-no because we've got a denominator, darn it, we've got a denominator with x in it. So I have to say, Mr. Denominator, you may never equal 0. So minus 5, negative 3x may never equal negative 5. Divide by negative 3. X may never equal positive 5/3. So at 5/3, there's going to be a gap, but I can use everything else. So my domain is negative infinity to 5/3 union 5/3 to infinity. And then finally they want me to do g times g. G times g of x is going to be g times itself. So I'm going to have 5 minus 3x times 5 minus 3x, which is going to be 25. Minus 15x minus 15x is minus 30x plus 9x squared. And my domain, I don't have any drama there, so my domain is going to be negative infinity to infinity. Okay? Alright, you try this one. They just want you to add the two and state the domain. Hit pause, come back when you're ready. And hopefully you got one. So they want me to add the two functions. So f plus g of x is going to be my f function plus my g function. well, nothing to distribute, so it's 5x plus 6 plus 5x squared. And they actually just left it like that, but you would not be wrong if you wrote it in descending order in polynomial form. There's no drama, no denominators with variables, no radicals with variables, so my domain is negative infinity to infinity. Okay, try this one. They want you to f times g. Hit pause, come back when you're ready. And hopefully you got 1. So f times g of x is going to be my f function times my g function. So distribute, and I get 8x cubed plus 14x squared. No denominators with letters, no radicals with variables, so my domain is negative infinity to infinity. Alright, this one they want you to subtract. Hit pause, come back when you're ready. And hopefully you got 4. To subtract f minus g of x, I take my f function, square root of x plus 3, minus my g function, cosine x. Obviously you can't subtract trig from square root, so you're done. We do have drama because we have a radical, so I have to say, Mr. Radical, you must always stay positive. Square, square, x plus 3 greater than or equal to 0, minus 3. X has to be greater than or equal to negative 3, which means this is my domain. So my domain starts at and includes negative 3 and goes to infinity. Okay? Divide, find the domain, hit pause, come back when you're ready. And hopefully you got 2. So to divide, f divided by g of x, I take my f function, which is the square root of x, divide by my g function, 2x minus 5. And I can't simplify. You can't divide a square root by a linear. So as far as math goes, I'm done. But the domain, we've got 2 sets of drama. We've got Mr. Radical that must always stay positive, and we have Mr. Denominator who may never equal 0. So if I simplify these 2 restrictions, square, square, x must always stay greater than or equal to 0. So close circle to the right. Okay. Then this one, add 5, 2x can never equal 5, divide by 2, so x can never equal 5 halves, which is like 2.5 something. So at 5 halves, we're going to get a jump. So my domain can be all of this and all of this, but it's got to jump over 5 halves. So my domain starts at and includes 0, goes to 5 halves, starts again at 5 halves, and goes to infinity. And the way they wrote it was, instead of using interval notation, they just said x has to stay greater than or equal to 0, comma, and x can never equal 5 halves. You can list it both ways. Most of the time, it's interval notation. Alright, so how do you combine functions using addition, subtraction, multiplication, and division? You do the math with the functions, just following order of operations, and then you have to get your domain. Alright, so we're going to be adding or subtracting functions from a graph. Okay, what you do is you write the ordered pairs indicated in the graph. Estimate several if they're not defined for you. If you're asked to add the functions, keep the x-coordinates the same and you add the y-coordinates. Okay, record the ordered pairs from the sum, replot them, and there's the sum of your 2 graphs. If you're asked to subtract, keep the x-coordinates, subtract the y-coordinates in the order you're asked to. Be careful. Okay? Alright, so on this one, what I'm going to do is I'm going to find these ordered pairs. Okay, for if I look at the f function, that would be 0, comma, I don't know, 0.5. Okay, this ordered pair would be 1, comma 2. This ordered pair would be 3, comma 0. This ordered pair would be 5, negative 0.5. Yeah, it's not quite at 1. This ordered pair would be at 6.3. This ordered pair would be at 7.3. And this ordered pair would be at 8.3. Okay, so now if I line up the other ones, you see how G, the first point for G, let me change colors. The first point for G has an x-coordinate of 1, so I'm going to record that one here, 1, -2. In other words, I'm not going to use that ordered pair because G doesn't have a point that lines up with it. Okay, my next ordered pair is 3, 1. My next ordered pair is, it looks like 5, 1. My next ordered pair looks like 6, 2. My next ordered pair is 7, 1. And G also doesn't have a coordinate that starts with 8, so we won't use that one either. So now what you do is you keep the x coordinates the same and you do the math on your y's. So f minus G is going to be 1, 2 minus a -2. That's going to be 1, 4. Okay, this one we're going to keep the 3 and 0 plus 1, so that's going to be 3, 1. Keep the 5. Oops, I'm not adding, I'm subtracting. 0 minus 1 is going to be 3, -1. 5, and this is going to be -0.5 minus 1, which is going to be 5, -1.5. My next one is going to be 6, 3 minus 2, so that's going to be 6, 1. And this is going to be 7, 3 minus 1 is going to be 7, 2. So if I plot my new points, either on this graph or theirs, I'll plot it on this one so you can see. I would do 1, 4, 3, -1, 5, -1.5, 6, 1, 7, 2. And if I connect those dots, there's the sum. Okay? Alright, so on the next one, alright, we've got this graph going on here. They don't specify points for me, so what I did was I added these like imaginary vertical lines. And I also did, okay, they told me the two functions. One function was x squared, the other function was 1 over x. The blue one is x squared because I know that's a parabola. 1 over x, those are the boomerang ones, so I know that this one is the red. This one's blue, this one's red. So what I did was I went to y equals and I typed in x squared for y1 and 1 divided by x for y2, and then I just went to my table because I picked coordinates 0.5, 1, 1.5, and 2. So if I look at my first function, my f function, the squared function, if I pick 0.5, I get 0.25, 1, 1, 1.5, 2.25, and 2, 4. My g function, I'm reading this x coordinate and this y coordinate. At 0.5, it's at 2. At 1, it's at 1. At 1.5, it's at 0.67 repeating. And at 2, y is at 0.5. So now I can add my functions. Keep the 0.5. Am I adding? Yeah, f plus 2. Keep the x, and I have 0.25 plus 2, so that's going to be 0.5, 2.25. This one's going to be 1, 1 plus 1, that's going to be 1, 2. This is going to be 1.5, 2.25 plus 0.67 is going to be 1.5, 2.92. This is going to be 2, 4 plus 0.5 is going to be 2, 4.5. So if I plot those points, 0.5, 2.25, so about right there, 1, 2, 1.5, 2.92, and 2 is 4.5. And it would look like that. Okay? And if I look, if I just check it, I went to my graphing calculator and I typed in f plus g. And if I graph, or there's my coordinates, just like I got here, and then there's my picture. Okay? Now, how come I didn't draw, how come I'm only drawing this part? Well, because that's the only where I started adding the coordinates. If I'd add all the ones back before here, you get this picture on this side. But we weren't doing that interval, we were just doing this interval. Alright, so, again, you can talk about doing this with graphs. Alright, next we're going to talk about composition of functions. It says, let f and g be two functions such that the domain of f intersects the range of g. The composition f of g denoted f little circle g, sometimes we call it fog, but it's called f of g, is defined by the following rule. F of g of x is f of g of x. You read these the exact same way. I don't like this notation, I prefer this notation. Okay? The domain of f of g consists of all x values in the domain of g, so whichever one is second, that map to g of x values in the domain of f. Alright, so what you do, it's easier just to show you. It says find f of g of 3 and g of f of negative 2. Sorry. I look at compositions as partying, okay? You have two parties to go to tonight. You have the F party that you're going to go to, and you have the G party that you're going to go to. You have to go to the party in the order that you're told. And the first party plan is to do F of G of 3. What that means is you're starting the evening out at the G party, okay? I'm getting a different color here. So this says we're starting the night off at G, and they want me to take 3 to the G party and figure out what I leave with. Well, I take 2, change x to 3, minus 3, that gives me 6, minus 3, which gives me 3. So when I went to the G party with my 3, I went and partied, and I'm leaving there with 3, so I must have broke even. So G of 3 is 3, so I can replace that with 3. And now I'm ready to go to my second party, the F party. And the F party says, bring me what you got, square it, subtract 1, and that's your prize for the night. So I bring my 3, square it is 9, take away 1 is 8. So I would say F of G of 3, after my night of G party and F party, I walk away with 8. Okay? Now they want me to do another one. They want me to find G of F of negative 2. So now we're starting to party at the F party, and we're bringing a negative 2 with us. So I have to start at F and take a negative 2. F says, whatever you brought, square it, minus 1. I'm bringing negative 2. Square that is 4. Subtract 1 is 3. So F of negative 2 equals 3. So this value in here is 3. So it's saying take 3 to the G party now. You're done at F. Had your fun. You're walking away with 3. You're going to G. G says 2 times whatever you brought minus 3. I brought a 3. Plug it in. That's 6 minus 3, which is 3. So at the end of the night, I started at F with a negative 2, partied, went to G with a 3, and I'm leaving with a 3. Okay? Alright, you try one, hit pause, come back when you're ready. and hopefully you got 536. They want me to find g of f of -4. This means you're going to start your party at f, and you're bringing a -4 with you. It's kind of like playing poker. You got -4 chips, okay, that you're going to go to the f function. So the first thing I do is find f of -4, which the f function, the f party, says, dude, whatever you brought, we're going to multiply it by 4 and add 5. So that's -16 plus 5, which is -11. So you went to f, you partied with -4, and you're leaving with -11. So we're finding g of -11 now to end our night. To end our night, we go to the g party, which says 4 times whatever you brought squared minus 5 times whatever you brought minus 3. And we simplify that. That's going to be 121. That's going to be positive 55. 4 times 121 is 484, plus 55 minus 3 is 536. So, g of f of -4 equals 536. Okay? Alright, when we do composition of functions with variables, it's the same thing. Like, for example, if you were finding f of g of x, this says you're starting the party off at g. But instead of bringing a number, you're just going to the g house and you're stealing the whole darn function. You're just saying, you know what, you have an x, I have an x, so I get everything because I have exactly the same thing you have. So I get the whole function. So you literally are going to take the g function and then substitute that in for every x in f. And if it's the opposite, you do the opposite. So this says find f of g of x and g of f of x. If I find f of g of x, we're still partying, two parties, the f party, the g party. But we're not playing with letters or numbers now. Now we're playing with letters. So this says go to the g party, find g of x. Well, g of x equals the square root of x. So that's what I got. That's what I'm leaving with. I went to g of x, but I have the same thing. I'm playing with x, which is the same thing they have. So I just get to take the whole function. So now I'm finding f of the square root of x. And my f function says 1 over whatever you brought minus 1. And the g function is the square root of x. Okay? And I'm done. My answer is 1 over the square root of x minus 1, except for you can't leave radical in the denominator, which I don't know. I don't know if Math Excel is going to make you rationalize your denominators or not. But if they do, if you remember, you cannot leave radicals in your denominator. So we had to rationalize them by multiplying the top and the bottom by the conjugate of the bottom, which would be the square root of x plus 1. So on top, I'd have the square root of x plus 1. And on bottom, if I FOIL this out, the square root of x times the square root of x is just x. That's going to be plus square root of x minus square root of x, which cancel because they're conjugates. And negative 1 times 1 is negative 1. That would be f of g of x equals the square root of x plus 1 over x minus 1. Yeah. And I don't know if they're going to make you find domain or not, but if they do, I'm going wrong right now. If they do, you would say, Mr. Denominator, you can't equal 0, so x can't equal 1. And this would say x, the radical has to stay positive, so x has to stay greater than or equal to negative 1. Okay? So your domain, let's see, this says can't be 1, and this says you have to stay greater than or equal to negative 1. So my domain would be negative 1 to 1, union 1 to infinity. Alright, then they want me to find g of f of x. Well, this says that we start partying with f. And that party says, bring what you got. but I got an x. So this says take out x and put x back in. So you're taking the whole the whole f function, and you're taking it to the g party. So I'm finding g of 1 over x minus 1. I'm finding g of this f function, which says go to g, which is the square root, take out x and put in what you brought, which I brought 1 over x minus 1. Well, this is the same as the square root of 1 over the square root of x minus 1. Now, it's not a binomial. I don't have to use the conjugate. It's just, I just have to multiply it by itself, and that'll get rid of the square root, but I got to do it on top. So on top, I'm going to have the square root of x minus 1, and on bottom, I'm just going to have x minus 1. Okay? And then you'd figure out your domain on there again. I don't know if they're going to ask you for it, but if they do, you the same thing I did up here. Okay? Alright, so on this next one, they want me to find f of g of x and g of f of x. To find f of g of x, this says go to g party first. So I say g of x equals 1 over x minus 1, and that's what I'm going to take to f. So now I'm going to find f of 1 over x minus 1. So this says, the f function says whatever you brought, square it, and subtract 1. And I brought a 1 over x minus 1. So if I square that, 1 over x minus 1 times 1 over x minus 1 minus 1, that turns into 1 on top, x minus 1 squared on bottom, minus 1. And I would just leave it like that. I mean, I guess you could get a common denominator and do all that stuff. Like I said, I don't know how far Math Excel is going to make you want to simplify. I would start off just typing in this, and then if it's not right, then they probably want you to get a common denominator and all of that stuff. But that would be f of g of x. Then to find g of f of x, this says start with the f function, which is x squared minus 1, and take it to g. In other words, I know what the f function is. It's x squared minus 1. So I got to take that to g, which says 1 over whatever you brought minus 1. And I brought x squared minus 1. Combine like terms, and I get 1 over x squared minus 2. And that would be my g of f of x. And again, you would do your denominator. Mr. Denominator can't be 0 if they wanted your domain. Okay. Alright, g of f of x, or f of g of x, g of f of x. If I do f of g of x first, this says start with the g of x function, which is the square root of x plus 1, and take it to the f function. So what they're wanting me to do is go to the f function with the square root of x plus 1. And the f function says square what you brought minus 2. I brought the square root of x plus 1. Square kills it, and you get x plus 1 minus 2, which gives me x minus 1. F of g of x equals x minus 1. And by the way, you would still have domain restrictions. Even though you don't end up with drama when you're done, it's inherent from the beginning, so you would still have to include, or not include, you'd have restrictions because of that radical. Okay, if they ask. Like I said, I don't know if they're going to ask you for domain. Alright, so then on g of f of x, that means start with the f function, which is x squared minus 2, and take it to g. So they want me literally to take x squared minus 2 to the g function, which says the square root of whatever you brought plus 1. I brought x squared minus 2. That gives me the square root of x squared minus 1. And no, you can't do the square root of each of those and get x minus 1. That doesn't work. Alright, so that's as far as I can do. So g of f of x equals the square root of x squared minus 1. And then you'd have to do your domain drawing. Alright, so let's try some different ones. These ones get a little more complicated because you have to add and subtract and get a common denominator and all that. So here we go. To find f of g of x means I'm starting with the g function, which is 1 over x minus 1, and I'm going to take that to the f party. So this says find f of 1 over x minus 1. So I take my f function, 1 over whatever I brought, plus 1, and I brought 1 over x minus 1. And we have to simplify this bad boy. Well, on top, there's nothing to do. On bottom, I need a common denominator, which is going to be x minus 1. So multiply the top and the bottom by x minus 1, and I get plus x minus 1 over x minus 1. That gives me 1 over, on top, I have 1 plus x minus 1 over x minus 1. That's 1 over, those ones cancel, x over x minus 1. Keep, change, flip, and that's going to be 1 times x minus 1 over x, which gives me x minus 1 over x. So I would say that f of g of x equals x minus 1 over x. Okay, then define g of f of x. G of f of x says start at the f party, which equals 1 over x plus 1, and take it to the g party. So I'm finding g of 1 over x plus 1. And my g party says 1 over whatever you brought minus 1. And I'm bringing 1 over x plus 1, which means I need a common denominator, which is going to be x plus 1. So on the bottom I got 1 over x plus 1 minus x plus 1 over x plus 1. On top, that's still 1. On bottom, and I'm subtracting both of these, so that's 1 minus x minus 1 over x plus 1. The 1's cancel, and I have 1 over negative x over x plus 1. And now I can keep, change, flip, keep the 1, change the times, flip the bottom, so x plus 1 over x, a negative, and that gives me negative x plus 1 over x. So g of f of x equals negative x plus 1 over x. Okay. Alright, let's try another one. We want f of g of x. So we're starting with the g function, which is the square root of 1 minus x squared, and we're going to take that to f. F says f of the square root of 1 minus x squared. Copy the f function, which just says whatever you brought, square it. I brought the square root of 1 minus x squared. Okay. When you square a square root, it cancels out, and I'm left with negative 1 minus x squared. So f of g of x equals negative 1 minus x squared. Why did I do negative? It's not negative, it's positive, sorry. Alright, so now we want to do g of f of x, which says start at the f party, which says x squared, and take it to g. So I'm really finding g of x squared. The g function says the square root of 1 minus whatever you brought squared. I'm bringing x squared. Square square, you get 1 minus x to the 4th, and no, you can't take the square root of that. That's your g of f of x. Dang it. Okay, and there's your 2 composition. Alright, you try one, hit pause, come back when you're ready. And you should get x. If I find, they want g of f of x. So I'm starting with the f function, which says x minus 5 over 3, and I'm taking it to g. G says, so I'm finding g of x minus 5 over 3. G says 3 times whatever you brought plus 5. I brought x minus 5 over 3. Simplify, those 3's cancel. That gives me x minus 5 plus 5. The 5's cancel, and I get x. So g of f of x equals x. Okay, try this one, hit pause, come back when you're ready. And hopefully you get 4. Alright, so if they want me to find f of g of x. So they're telling me to start with g of x, which is 8x minus 12. I'm going to take that to the f party. The f party, so f of 8x minus 12 equals the square root of whatever I brought plus 8. I'm bringing 8x minus 12. That gives me, combined like terms, the square root of 8x minus 4. And there's my f of g of x. But why is this the answer then? Well, because what he did was inside that radical, he factored out a 4. And that would be 4 times 2x minus 1. There's a law that says when you take the square root of a product, you can square root them separately. Well, the square root of 4 is 2. And I can't simplify that anymore, so I leave that underneath, and that's where they got f of g of x equals 2 times the square root of 2x minus 1. Okie dokie. Alright, so how do you write composite functions? You can either use this notation, or you can use f of g of x. How do you simplify a composition function? You plug in the second function to the first function and simplify. It's basically substitute and simplify. Alright, we are done. So, happy homeworking, and I will see you next time.